Good morning, everyone. I'm really happy to be here today. By way of introductions, I'm Asha Paulos Johnson, and I'm responsible for creating and implementing a data and analytics strategy for the enterprise at GE Healthcare. And I have with me today AB, who leads the cloud data platforms on my team. Data and analytics is foundational to the success of GE Healthcare's digital transformation and market competitiveness. This use case focused on a heavy platform transformation that GE Healthcare drove in the last year to move from an on-prem legacy data platforming strategy to a cloud-native and completely service-oriented strategy that enables us to really gain both speed and scale as an enterprise. This was a huge effort for a 17 billion company and successfully executed by a diverse global team in the middle of the pandemic, and it enables GE Healthcare to leapfrog in its enterprise data analytic strategy. So I will provide a business and technology overview, and AB will do a deep dive into the platform architecture. To give a brief overview of healthcare, we are a leading global medical technology and digital solutions innovator, enabling clinicians to make faster, more informed decisions through intelligent devices, data analytics, applications, and services. You can see some of our statistics on the slide and a fairly complex enterprise with customers all around the world. Our business strategy is to focus on growth in digital-led solutions and technology innovation, all in the pursuit of our purpose, which is to improve lives in moments that matter. So the data analytics strategy we have as an enterprise internally is foundational for us to achieve our business strategy. Now, as we kind of look at some of the key trends, that are shaping our data analytics strategy, a lot of things have happened in 2020 while we were kind of trying to build out this platform strategy. I think the first thing is really how external data has started to play a critical role in our whole ecosystem. The contextual awareness to support decisions not only matters with all our internal data from our enterprise and our machines, but also on market and many external forces that are shaping it. Combined with this is the whole regionalization and security needs that we need to follow, like GDPR, the requirements on China and things like that. When we start looking at how the business is shaping up, the need for responsiveness on how quickly we can turn data analytic solutions has significantly increased, especially for domains like commercial, marketing, sales, which are very customer facing. There's more need of real time and near real time data as compared to batch processing. COVID has changed the expectations on the turnaround time of delivery. And obviously, a big shift of data culture is starting to happen across the world as the world becomes more digital. So when we look at these key trends, we kind of looked at where we are going as a business and kind of arrived at four guiding principles, which really shaped our strategy. The first is really the platform, which is what we will go through in a little bit more detail in the next slides. To have an integrated data ecosystem that is nimble, that is flexible, which is purpose-built, which is secure, which is scalable, I think is extremely important and foundational for any large enterprise which want to really do scale and speed together. And obviously, all of data analytics is really built on the data in this whole ecosystem. So investment in how we manage data, how we improve quality, how we catalog, how we look at lineage, how we enable visual discovery, those kind of things are very, very important. The third thing is, if you really want to do scale, you cannot do it by monolithic or very small development efforts, right? You cannot have monolithic development efforts. You need to really get to a service-oriented enablement of both data and analytics and even insights. So a framework that enables reuse is extremely important principle here. And the final thing is, this is not just about a technology organization. This transformation needs everybody to play their part. So having a strong data literacy program that is tied with your platform strategy and investment in data management and service-oriented strategy, I think is key to converting this strategy to a reality. So these are kind of the guiding principles for how we thought about what our strategy for transformation needs to be. So with that, came together what we call as the GE Healthcare One Data Platform, which is essentially trying to solve for the different challenges that we see in coming into our horizon, the different trends, combine it with our data strategy, and really focuses us to enable pulling together all of the data, manage it well, on a strong, scalable, secure platform, and then federate it and build out products in a very democratized way. And this then acts as the data and analytics operating system for the healthcare enterprise. So when we look at the different components of this whole operating system, right, it kind of consists of 8 key things. And then it serves multiple personas in different ways. So as we look at bottom to top, the bottom layer is really the different types of data coming together, which serves needs of the enterprise, which has a lot of external and public data, as we talked about earlier, and then the data of the equipment that we have installed in various sites. All of this kind of gets mashed up through a process of different data pipelines depending on the type of need and the type of data. And then this gets moved on to a data store if needed, which consists of both a data lake and a data warehouse, and then served out as a service or as an analytic on which a whole bunch of personas build products. On the left hand and the right hand side, if you really look at it, what you see is two very important components of this platform. One is really around the security and regionalization needs like access control and GDPR, all integrated into this platform, which is very critical for a business like ours. And then on the right hand side, the whole data management process, looking through cataloging and enabling democratization with discovery. Now, when we really look at the consumers of this platform, right, it really varies from both humans, systems, and customer or end business users. So we have a lot of information consumers. These are primarily the folks who are looking for reports or BI solutions which come out of a warehouse. We have data owners and stewards who are looking at the quality and monitoring that for the data. Then we have a variety of folks who want to build stuff, the data engineers, the scientists, the architects, the engineers, and developers. And then eventually we also have system consumers, which are downstream systems or other products where you use embedded insights or embedded AI that comes out of this platform. So if you really see, this is a single ecosystem that caters to pretty much every kind of scenario a large enterprise like ours has. It's very nimble, and then it also provides all the key features that is really required for it. And what it really helps us do is to act and have a foundational operating system for analytics that then helps our business to do both scale and speed. With that, I will hand it over to AB, who will walk us through the architecture and take a deep dive on this platform. Thank you.
It's a great pleasure to be part of this Data and AI Summit. As Asha mentioned, my name is AB Varghese. I'm the leader for the platform and cloud services in the data and analytics organization of GE Healthcare. I would like to walk you through the data platform architecture of GE. By the end of this, you will be able to understand that we architecture our one data platform to meet the speed and scale, to be nimble and flexible while providing capabilities of federated analytics. Okay. Sorry. What you see in this slide is the pictorial view of the one data platform on cloud. This is a busy slide, so please pay attention to this closely and allow me to walk through this slide from left to right. Let's start with the data sources. We categorize this into mainly two types: enterprise data sources and machine data or IoT data sets. Enterprise data sets. These are traditional data sources like our ERPs, CRMs, EDW, and so on. These data sets are very structured, RDBMS types of data. Machine data or IoT data sets, these data sets are mostly unstructured, or some are type of time series data, video or text recognition data. We have all kinds of data. We build data pipelines to extract this data from the sources and transfer to the data lake. There are three types of data pipelines we build. First is the data replication. Here, the data is extracted or replicated from the sources to the target data lake. Here, source data looks like exactly the same on the target side. We are using tools like HVR to build the data replication. The second is the change data capture or incremental data pipeline. Here, after the initial load, we bring only delta or incremental data from the sources. This is one of the preferred and primary ways to feed the data to the data lake. And the third is the data streaming. There are some data sources from enterprise side and IoT side we bring in real time. We feed this data to the real-time processing engine and to the data lake. The real-time processing engine is built on top of technologies like Spark, Spark streaming, Kafka, and EMR cluster. After processing, real-time data finds its way to a real-time dashboard or turns into either a notification or a systems action. The real-time dashboard provides consumable insights for decision making. Now let's turn our eyes to data storage. It consists of two components, a data lake and a data warehouse. The data lake is the place to store all the raw data or the data that has undergone a very simple processing. Here, all types of data are stored in the data lake. Our data lake architecture, we separated storage and compute. Since we separated storage and compute, both can grow horizontally and separately. Our entire data lake computation is happening through Spark jobs. We are using EMR cluster and S3 storage to build the data lake with heavy focus on Spark computation. Let's talk about data warehouse. Some data from the data lake we extract, transform, and load in the cloud data warehouse. These data are very structured. We are using Redshift as our cloud data warehouse. Data analytics are built on top of this data warehouse using data visualization tool. So many of business outcomes, business outcome dashboards are built on the data from the warehouse. Let me briefly touch on machine learning. By the way, machine learning itself does not happen in real time. It is an elaborated process, and the system requires significant time to analyze a high volume of data, which usually covers the period of multiple years to come up with valuable models and patterns. These models help the system to make real-time decisions. We are using SageMaker to build, train, and deploy machine learning. All these are happening in one single data ecosystem and very connected ecosystem. Since all data is on one data ecosystem, we removed some of the technical challenges like data quality, data preparation, storing, securing, and cataloging data. Data as a service. Here we talk on data or data democratization. Data democratization is the process of making data accessible enterprise-wide by creating a shared framework of metadata across different business verticals, especially using microservices. Data democratization pushes organizations like us to rethink how we manage, distribute, and consume data. Here, from the features perspective, we integrated enterprise data and machine data together to one ecosystem. And we have wing-to-wing automation of services enabled. We have highly scalable API integration with the certified data sets, and which enable the edge acceleration on many of our regions. Let me talk about some of the benefits we get out of data democratization or data as a service. It's a single source of truth. The data, we have a single source of truth on the data. And it supports self-service through data cataloging. And we have accelerated our business strategy or business outcomes through the data democratization. Let's move to AI as a service or democratizing AI. When we talk about AI, we're talking about a stable, reliable, and secure platform for predictive analytics. We enabled AI ops for event-based architecture or event-driven automation for platform discovery and recognition. We transformed our IT operations using machine learning. We enabled Data Notebook, which is shared by multiple data scientists securely, and we created a framework for the data, creating the data models and so on. Some of the benefits we're getting out of it, we enable cognitive computing solutions for decision-making and problem solving. We moved from a descriptive analytics or descriptive and perspective analytics to predictive and cognitive analytics. So we talked about data platform architecture. We talked about data democratization. Now where we all comes into play is the cloud infrastructure and automation. We spend a lot of time on cloud infrastructure or infrastructure and platform as a code. This platform as a code enabled us to deliver cloud services in high velocity, securely, with less complexity, faster delivery of features, and more stable operating environments. We are using tools like Jenkins, Terraform, Ansible, and GitHub to build our DevOps. Security is in the forefront of everything we do. All our cloud services are integrated with the enterprise security tools using SecDevOps model. All data is encrypted. Access authentication and authorization are enabled through multi-factor authentication. We enable Data Lifecycle Manager for disaster recovery and backup compliance. All our users get a home directory on our S3 bucket across the regions. Talk about analytics-driven automation, AI ops. We are using Lambda heavily to build the analytics driven automation, Lambda function from AWS heavily for the analytics driven automation. Let's talk about something we call internally as auto tag. So auto tag is an event based architecture for better cost visibility and improved security governance. Anything we do inside the cloud infrastructure, an event is created on CloudWatch. And we build analytics on the event to build automation and drive and enable the IT operations transform the IT operations through machine learning. And the second is S3 bucket lockdown. If you Google S3 bucket leaks, you see a lot of company went with the security concerns of the S3 bucket going public. We created a Lambda function to monitor our S3 buckets, and whenever an actual change happens, it's automatically remediated and sent alerts to the system owners or the enterprise architects. And the third is auto instance scheduler. Again, we noticed that many of our developers work in the same time zone. So we created a Lambda function to shut down AWS services or instances for almost 12 hours a day. It runs only for 12 hours. So we are actively shutting down and starting the instances for cost optimization. To wrap all this up, we have a highly scalable, nimble data platform with right data that is democratized and consumed by an increasingly data literate organization is a true multiplier and will enable exponential growth. With our one data ecosystem, we were able to accelerate our business analytics strategy and business outcomes. Thank you for the time.